And week 4, MyMathLab examples. One I chose is question number 11, only because, well, the work is easy, but just worded sort of strangely. So in here they're saying find the limit as x approaches 3. And then they said put f of x right here. And then the answer for f of x is this -2. So you take the -2 and you substitute it right there. So this is going to be on top a 7 minus, so they have 7 minus, and then substitute in the -2. And then on the bottom they have x, which is this 3 right here, so substitute that in. And then it goes plus the g of x, and the answer for the g of x is a 4. So that was the hard part. Now simplify the top. This is going to become plus, so 7 plus 2 is 9. And on the bottom, 3 plus 4 is 12. And if you put that answer, they're going to say it's wrong because you need to simplify. So with a 3 and a 12, each of them could be divided by 3. So divide by 3 and divide by 3. On the top, that's going to leave 3. On the bottom, 12 divided by 3 is 4. And so my final answer in simplified form is 3/4. And the next one that I chose is number 12. So sketch a possible graph that satisfies these conditions. So f of 0 equals 2. So that means when you plug in 0, it equals 2. This one is incorrect. That's not equal to. Up there would be a 2, but that one has an open circle. So this one already cannot be it. F of 0 equals 1, 2. That one is possible. This one also has an open circle there, so it cannot equal a 2, so this one is out. And f of 0 equals 2, that has a solid circle. So these two are the possibilities so far. This one is saying if you're on the left side of 0, the y value is going to be a -1. So if you're on the left side of 0, the y value is going to equal a -1. That does not look right. This one says if you're on the left side of 0 and you follow it, it's going to take you to a y value of -1. That seems to be correct. Because this is a limit, the open circle doesn't matter. That is perfectly fine. So far the D is the winner. And then with this one it says when you're on the right side of 2, it should take you to a y value of 2. And it does. So this one is the winner. And so basically, when I make the lecture, I look at all the homework questions and make sure that I cover everything. And then also I go back after I've done the lecture and see, are there any that they word sort of strangely or that I should go through? And let's see what this one says. So this one is basically saying you have this function to the left of 0, and then you have this function to the right of 0. And then their question is about what's happening at 0. So I could graph it, but I think it would take more time than we need because basically this is saying less than, so this is the left side. This is saying greater than 0, so this is the right side. So basically when they say do the right side limit, then you're supposed to be using this, so you're supposed to be using this function. And if you plug in 0, then it's going to tell you 12 plus 0 squared, which equals 12. So this answer is 12. On the left side, which means use this one, then use this function, and if you plug in the 0, you're going to get 12 minus 0 squared, which equals 12. So this one, the answer is 12. This one is saying what's the limit when you consider both sides? And when you consider both sides, they're the same, so the answer has to be 12. If these two would have been different, then I would say this one does not exist. But when these two are the same, then it's the same answer. And finally, it says, what if you plug in 0? Well, I did that over here, and I got 12 both times, so it must be a 12. And then on to question number 20. Find equation of the following line. It's a vertical line. Okay, so when you have, I'm going to do both vertical and horizontal. So here's a horizontal line. Excuse me. Here's a vertical line. This one, you would just find out what the y value equals. Let's say that it's a 2 right there. And then you'd say the equation of the line is y equals 2. That's it. Let's say for this one over here, this x value is 3. Then for a vertical line, you would just say x equals 3. So for vertical, it's x equals a number. For horizontal, it's y equals a number. They say vertical. So that means I can already say it's going to be x equals, because it's going to be like this, a vertical line. And then they say that the x value is 5, and it doesn't even matter what they put right there. If the x is a 5, that's basically replacing this, so x equals 5, there it is. And there was only 2 others that sort of piqued my interest. Question number 23. So refer to this graph to the right, okay. Describe the behavior as x approaches infinity. So then what's happening to the right side of the graph? So on the right side of the graph, here it's leveling off at this value right here. And if you follow this straight across, it's going to take you to right here. And let me see if I can zoom in. So when I follow this across, that's going to be this line right here. And since this is -2 and this is -4, this red line must be at -3. So on the right side, it's becoming a 3. Select the correct answer. There you go. And then this says the limit does not exist because it's neither positive infinity. Oh, and it's neither positive infinity or negative infinity. So this is not the correct answer, but let me show you what they're referring to. The limit does not exist, and it's not positive infinity or negative infinity. So this is something we haven't done in this class, but let me just show you real quick. If we had trigonometry as a prerequisite, then we could do the sine function. And it doesn't matter if you know what sine is or not. Just imagine a wave that goes up and down forever. Then the limit does not exist because there's not one answer. Sometimes it's up here, sometimes it's here, sometimes it's down here, sometimes it's back up here. So there's not just one answer. Also, it's not going down to negative infinity. It's not going up to negative infinity. So this is an example of what they were talking about with b. And this function does not do that, but I just wanted to point out that's what they're talking about. The limit does not exist, and yet it's not negative infinity. It's also not positive infinity. That would be the sine wave. And number 29. So this is actually like the very last one I did in the week 4 lecture. So vertical asymptote, I always start there because that's very easy to do. You just put the bottom equal to 0. And then this you could factor as x minus 4 times x plus 4 because that's the difference of squares. And when you set this one equal to 0, you'll move the 4 to the other side and it's going to be x equals 4. When you set this one equal to 0, you move the 4 to the other side, it's going to become x equals -4. So that's the vertical asymptote. So use a comma to separate the answers as needed. This is actually the horizontal asymptote. So if I answered this question, then it would give me the vertical, and then it would say x equals, and then they would have a blank, and then I would need to say 4 comma negative 4. So that's how to enter the answer right there. And then this one's pretty easy, because remember when you're doing the horizontal asymptote, you say, well, x squared is what's controlling the top, plus 16 doesn't really matter. X squared is what's controlling the bottom, minus 16 doesn't really matter. So after that, the x squares can cancel, and then all that's left is 7. And that's basically saying y equals 7. So y equals 7.